Why do capacitors fail catastrophically? Imagine a tiny component in your electronic device suddenly exploding or sparking without warning. That's often what happens when a capacitor fails catastrophically. Capacitors are like small energy reservoirs, storing electrical charge for circuits. But sometimes, they fail in a dramatic way that can damage the entire device. This kind of failure is usually quick and destructive, not a slow wear-out. So, what causes this sudden breakdown? The main reason is dielectric breakdown. Inside a capacitor, there's an insulating layer called the dielectric. When voltage exceeds what the dielectric can handle, it breaks down, allowing current to pass through uncontrollably. This sudden passage of electricity causes sparks, smoke, or even fire. It's like a tiny explosion happening inside the component. Once the dielectric fails, the failure feeds itself, making the damage worse very fast. Electrical overstress is a common culprit. If a voltage spike hits the capacitor beyond its rated limit, the dielectric can instantly degrade. Think of a power surge during a lightning storm hitting your electronics. That surge can push the voltage past the capacitor's maximum rating, causing immediate damage. Thermal stress also plays a big role. High temperatures speed up the aging process of the dielectric and electrolytes in electrolytic capacitors. Overheating can cause the internal layers to crack or evaporate, leading to shorts or open circuits. Sometimes, a sudden temperature rise causes the capacitor to fail instantly. Mechanical stress is another factor. Vibrations, shocks, or improper mounting can create tiny cracks or delamination inside the capacitor. These microcracks weaken the insulation, and under electrical stress, they can cause a quick dielectric breakdown. Manufacturing defects also contribute. If the dielectric layer is too thin, poorly dried, or if there are impurities, the capacitor becomes more prone to sudden failure. Over time, dielectric materials can become brittle, especially if exposed to moisture or corrosive environments, making failure more likely. Some types of capacitors, like metallized film ones, have a self-healing property. When a small breakdown occurs, the metal around the fault vaporizes, isolating the damage. But if the fault is too large or the self-healing process fails, the capacitor will fail catastrophically. In real-world failures, these causes often combine. For example, a capacitor in a power supply might experience a voltage spike, high temperature, and vibration all at once. This combination can lead to a sudden destructive failure. To prevent this, engineers choose capacitors rated for higher voltages and temperatures, add safety margins, and ensure proper mounting and handling. Regular checks can spot early signs of damage, avoiding sudden breakdowns. Understanding these failure modes helps us see why capacitors sometimes explode or burn out unexpectedly. It's a mix of electrical, thermal, mechanical, and material factors working together. Knowing this helps design more reliable electronics and avoid costly failures in the future.